Pascal's law. We understood that the fluids can exert pressure. Now, Blaise Pascal identified that for an enclosed fluid, if you apply an excess pressure at one end, that pressure is transmitted through the fluid undiminished in all other directions. And this is called Pascal's law. That is, if you take an enclosed fluid and apply an excess pressure at one end of that enclosed fluid, the pressure will be transmitted through the fluid in all other directions undiminished. And to verify that Pascal's law, let us consider a spherical bowl attached with 4 pistons. 1, 2, 3, 4. And you can identify the area of this piston is A, this is A by 2, this is 2A, and this is 3. And a liquid is filled in. Airtight, no air gap is there, enclosed fluid it is. Now, if you apply a force F downward on this piston, you can find that the pistons here, and here will be moving outward. Will be pushed outward when you apply force at this particular point. This piston will be going down. Accordingly, all other pistons will be moving outward. Okay, now what we are doing is, as we apply a force here, a pressure is created here that is equal to F by A. Now, if we want to make these pistons back to the same point as they move outward, if I want to move this piston to the initial position, I have to apply a force of 3F into back to this. Like that, if I want to move this piston back to its initial position, then it is found that it requires 2 times F. And here it is found that F by 2 is required. So by measuring the force required to push these pistons back to its original positions, we found these things. Now let us see. If 3 times force F is required here to move this back to its original point, then there will be a pressure of 3F by 3A. And here it is found that 2F is required. That means 2F by 2A is coming there as pressure. And the other end, it is F by 2 by A by 2. You can see that all these pressures are equal and it is found to be equal to F by A. This F by A is the pressure exerted at this end of the enclosed fluid. So this pressure will be transmitting through the fluid in all other directions the same way without any loss. So Pascal's law is well explained, and based on this particular law, we got many applications in our daily life. For example, hydraulic machines all works on this particular principle. Hydraulic lift, hydraulic jack, vehicle brake system, car, buses and all, there also we are depending on the Pascal's law for the braking system. So wide applications are there for Pascal's law. So I will discuss only one particular case, that hydraulic lift, how it is working on the principle of Pascal's law. So the hydraulic lift in the simple form, if I take a small area and a large area portions coming. Okay, and here there is a piston attached and a platform here, and here also a piston attached and a platform also. Okay, and then here I am keeping a weight of, let us say, force F is kept here, and that F is acting on an area A, and here there is a fluid which is enclosed in between. A fluid is enclosed, and this fluid, whereas it is enclosed, airtight, as you keep a force on this one, apply a force on this piston will be going down, and you can see that the pressure transmits through this and reaches here, pushing this piston up. Now you can see that this upward motion can lift a particular weight over here, means it's a heavy weight. If I keep over here, let it be X. X is the weight I am keeping here, and you can see that this piston will be moving slowly up, lifting this large weight. So you apply a small weight over here, and here it is making that lift, making it to lift a large weight. Now how it is happening? Let us see that suppose this area is 10 times E, suppose. Then according to Pascal's law, what coming here, at this particular point there will be a downward pressure P coming. That downward pressure P will be equal to F by A. Then according to Pascal's law, this pressure will be reaching this particular point. So at this particular point there is a pressure P upwards, and this P upwards will be equal to F by E. That means X divided by 10 times C. So these two pressures must be equal. So you can find that X is equal to 10 times F. So a small force applied at this particular point is now deriving a large force to be lifted from this point. Of course, we have to ignore the effect of gravity for the liquid here. Okay. Atmospheric effect is not coming, enclosed fluid it is, and you can see what is happening here. So by applying a small force, we can lift a large weight on the other. This is a simple form of a hydraulic lift. So like that hydraulic press packing system, hydraulic brake also acts based on this. Braking system, we are applying a small force on the brake pedal where a small tube is coming, and that opens to near the tire with a large area, so that force multiplies and presses on the wheel with a greater force. So that you can refer from the text and identify. So the effect is all the same. Small area, small force, a pressure is created, that it's transmitting to a large area and delivering a large force. So this is all about what we call Pascal's law.